Greetings to the respected faculty. I am Lasya Mandapati from CSC AI and MLB section. My roll number is 24951A6686, and today I'll be presenting on the project Intrusion Detection System using system call monitoring. The focus of this project is on developing a machine learning based system capable of detecting intrusions by analyzing system call behavior. In the next few minutes, I'll take you through the objectives, methodology, results, and future directions of this work. The rapid growth of technology has also increased cyber threats, making traditional security systems less effective. To handle this, intrusion detection systems, or IDS, play a major role in monitoring and identifying abnormal behavior. In this project, I've built an intrusion detection system that relies on system call sequences to distinguish between normal activities and abnormal activities, which are possible intrusions. Every process in an operating system makes system calls. For example, opening files, creating processes, or sending network data. And these calls form a behavioral signature. By using Python and machine learning algorithms such as random forest and SVM, the system learns normal patterns and flags unusual ones as intrusions. The approach was tested on unknown datasets like NSL-KDD and ADFA-LD, and even though the results are from a small sample, it demonstrates that system call-based behavior analysis is a powerful cybersecurity method. Traditional signature-based intrusion detection systems depend on a predefined attack signatures. The problem is, these systems cannot detect new or unseen attacks, also known as zero-day attacks. Moreover, malicious programs often disguise themselves as normal processes, making them harder to detect. The key challenge addressed in this project is to create an adaptive IDS that learns from system level behavior instead of relying on pre coded attack signatures. By monitoring systems, calls, and identifying anomalies through machine learning, we aim to build a system that can detect intrusion even if they've never been seen before. An intrusion detection system, or IDS, is a critical part of modern cybersecurity. It continuously monitors network traffic or system activities and raises an alert when it detects something suspicious. In this project, I focused on system call monitoring, which captures low level interactions between processes and operating systems. Each process performs a specific sequence of system calls, and any deviation from its normal patterns can indicate an intrusion. By combining this behavioral monitoring with machine learning algorithms, the system can automatically classify activities as normal or malicious. This approach enhances the traditional IDS by introducing intelligence and adaptability, which are essential in today's evolving cyber landscape. The main objectives of this project are as follows: 1. To design and develop a machine learning based intrusion detection system using system call monitoring. 2. To collect and analyze system call traces from both normal and attack scenarios. 3. To, to extract meaningful features from these traces for training the model. 4. To evaluate the model's accuracy using metrics such as precision, recall, and F1 score. And finally, to demonstrate that system call monitoring can serve as an effective method for identifying zero-day attacks. In short, this project aims to explore a lightweight, data-driven approach to intrusion detection. The concept of system call-based intrusion detection was first proposed by Forrest and colleagues in 1996, who showed that every process has a unique system call pattern. Later, Warrender in 1999 explored alternative data models for better detection accuracy. In the early 2000s, Liao and Wemuri introduced machine learning algorithms like SVM and KNN to classify process behavior. More recently, deep learning models, especially LSTMs, have been used to capture the time sequence of system calls with great success. For this project, I refer to datasets such as NSL-KDD and ADFA-LD, which contain label system call traces. The literature shows that combining behavior monitoring with ML provides higher adaptability than signature-based methods. The architecture of my proposed IDS consists of five key modules: data collection, capturing system call traces using datasets or tools like Trace and AuditD; pre-processing, converting raw system calls into numerical form or frequency-based features; model training, using machine learning algorithms like random forest to learn and attack patterns, normal and attack patterns; intrusion detection, classify new data in real time as normal or malicious; evaluation, measuring how well the model performs using metrics such as accuracy, recall, and precision. This architecture ensures that the system is modular, interpretable, and efficient. Methodology. The methodology follows a systematic process. First, problem definition, identifying the need for system call based ideas. 2. Data collection, using sample system call datasets. 3. Feature extraction, representing system call behavior numerically. 4. Model training. Here we apply the random forest classifier using Python and scikit-learn. And finally, 5. Testing and evaluation, where measuring data sets, accuracy and misclassification rates occurs. This approach allowed me to simulate intrusion detection effectively within a limited dataset environment. The implementation was done in Python 3.110 using libraries like Pandas, NumPy, and scikit-learn. The data was split into training and testing sets, standardized using standard scalar and trained using the random forest classifier. Code then generated a confusion matrix and classification report to evaluate detection performance. In a real world scenario, this setup can be extended to use live system call logs from Linux processors. This demonstration shows how simple yet powerful Python based models can be for behavioral intrusion detection. After running the model, I obtained the following results. The confusion matrix was 1101 and the overall accuracy was 66.67%. This means that 2 out of 3 samples were correctly classified while one attack was misclassified as normal. The precision for attack detection was perfect 1.0, but the recall was zero point 0.5, indicating that the model missed one attack instance. Although the accuracy isn't perfect, it reflects real world conditions where anomalies can be complex and sometimes overlap with normal activity. The obtained accuracy was 66.7%, which shows that the ideas works moderately well given a small dataset. With larger and more diverse data, the model's accuracy would improve significantly. This result validates that system call monitoring is a feasible and effective technique for anomaly detection. To summarize, the project successfully demonstrates an IDS capable of detecting abnormal activities using system call patterns. With a detection accuracy of 66.67%, the model proves that behavioral based approaches can complement existing cybersecurity systems. Future work. I plan to use deep learning models like LSTM to handle sequential dependencies. Real time detection can be implemented using SysDig or audit tools. Extending the system to cloud or IoT devices will make it more practical for real world use. Lastly, creating a hybrid IDS that combines anomaly and signature based detection could improve both accuracy and the reliability of the program. Thank you for your time and attention. This concludes my presentation on intrusion detection system using system called Monitor.